Hello, this is Paul from Foresight Tech. In this video, let's prove Theorem 3.2.3, which is the additional properties of dot product in n-space. And we proved some basic properties in Theorem 3.2.2, similar as B, C, D, which is a distributor. Can you see? And this is another three type of distributor. So you can use the same way to prove, okay, similar way. But here I will introduce another way to prove this B, C, and D. So the first is just a simple, okay, the zero vector. Do dot product, of course, should be zero scalar numbers. And the last E, you see, as homogeneity, right? Similar with the one we learned in Theorem 3.2.2. Okay, the original is K associated with U, but this time associated with V. I also will introduce another way to prove for E. Okay, here. So let's go A first. So A is quite easy. Somebody say V, the back of the V is V1, V2, that goes to Vn. Okay, so the components. Therefore, we can directly 0 is a vector, dot times V should be the sum of product, which is 0 times V1 plus 0 times V2, that plus 0 times Vn. Of course, should be 0, right? And the same, okay. The same for you also can calculate what is V dot. Okay, so we can find another. See, the second part is V dot O. Okay, V dot 0. Remember the last theorem we have the commutative. It's just a commute. So this is a 0 dot V. Of course, it's 0, right? So here is the commutative, which is Theorem 3.2.2. Okay. So A is true definitely. So now we look at B. Distributor. A kind of distributor W is the outer side of the parentheses. So we look at B. How do you say B? You can follow the same way we did in the Theorem 3.2.2. But here, yeah, we can just use the result from Theorem 3.2.2. Okay, so by commutative, okay, we switch. So you can see easy to get the answer. Start from U plus V dot W. Can we do distributive? Yes, first. Commutative. Okay, Theorem 3.2.2. Let me make sure. Yes, the previous Theorem 3.2.2. See, what do we have? We have this equals W dot U plus V, right? And then commutative, and then distributive, and then distributive. So this should be, let me put here, equals W dot U. And see, we can distribute here to here. So we get a W dot V. And this type of distribution, so I already proved it, okay, so in the Theorem 3.2.2, just a check. So this is true. And then again, distributive again, so not distributed, sorry, commutative, so U dot W, and then plus V dot W, again, commutative, so they had the previous 3.2.2, commutative, see, so we get the answer. Therefore, we can distribute the W into U and V, right? So which is B. So B is true. Before we go to C, I need to use the results of E. So let's prove E first. Okay, prove the homogeneity this type. E first. So we go to E. What is E? See, homogeneity. Let me go from the right to left. So the right is U dot K times V, right? So how to find this? First, commutative, okay? Commutative, which is a theorem 3.2.2. Again, we can write U K times V and then dot U, okay? And then again, okay, but the homogeneity, right? So we can factor the K out. So this one will go to K times V dot U. We already proved this theorem 3.2.3.2, so we don't need to repeat. And then commute again. So this equals K times U dot V. Okay, commutative again. Okay, so simplify. You see, is this the result? So the finally K, and they can take out of the dot product, right? Okay, so this is E, and then there's to the C. So now I can use the distributive and also the result E to prove the another distributive of C. Okay, so first this minus. What is minus? Minus means plus the negative one times W. I use that one. So now C is U dot V minus W. Can we distribute? Yeah, we can, because this I can write into this. This is V plus negative 1. And then this minus means what? Means plus the negative of W, or the inverse of W. Inverse of W, which is negative 1 times W, is the same that definition. Okay. And then we can distribute it, right? Distribute. We just see this is a vector. Okay. The distribution. Now what do we get? We will get U dot V. So plus U dot here should be negative 1 times W, right? And the distribution should be, we already proved in theorem 3.2.2, distributive. Okay, almost. See, U dot V and U dot negative W. Here's negative W. So we just prove this homogeneity. Okay, so this negative 1. We can pick this out. Can we? Yes, we can. Okay, so therefore this should be equals U dot V a copy, and then plus negative 1 up for the outer side, and then U dot W. Okay, for the parenthesis, and this is E. We just proved. Okay, so just check. This number is this is a number, and this is not a number. Plus a negative number, of course, is minus. Okay, therefore, it's just the number system. So we get the answer is U dot V minus U dot W. You see, definitely we can distribute it. Look at the last D, another distribution. Of course, we just switch commutative. Okay, we use the commutative and then use the result C. We can get the answer definitely. The last, so look at the last one. D is, let me check. Okay, so u minus v dot w. Can we distribute the w inside? Yes, we do. Which is u minus v and then dot w. Excuse me. So first, okay, commutative. Okay, now simplify, which is w dot u minus v. No problem, right? And then now you know we can distribute no matter this minus because we just proved, okay, number 4, which is C. So we use the result of C, and then we can distribute it. So therefore w dot u minus w dot v. Almost see u dot w dot u is just the commute, switch the order again, right? So switch the order commutative. Use the commutative, just switch the order. That way we get a u dot w minus v dot w. See, so finally the u dot w minus v dot w distribute works. So that's the proof for the theorem. That's all. Thank you.